Hello again. In this video, inshallah, we will talk about the part number 23, which is over here. We can find it. Solve mathematical and real life optimization problems. So, in here, from the word optimization, so we need to choose the best only if it's maximum or minimum. So, all the time in these questions, they will ask you to maximize or to minimize a specific value. So for me, the steps for solving a question about optimization, it's very important to read the question carefully, to write all the relations that you can find them in the question. Now, before start finding the derivative, try as much as possible to have only one variable. Okay, so you will use the substitution method for substituting the second or the third variable. Okay, so let's see how we can solve these questions, how to find the best values, the maximum or the minimum values of specific relation. So in here, starting with a three-sided question one, okay? So three-sided fence is to be built next to a straight section of river. Okay, so in here we have a three-sided fence. So only we have three sides only. So it's very important to focus and read the question carefully. Okay, so which forms the fourth side. So the straight section of the river, it will form the fourth sides for us. Okay, so the fourth side, it will be the section of the river. So I'm not going to fence that side actually, okay, of the rectangular region. So the enclosed area is equal to 1800 feet square. So let's start by just graphing the shape that we have over here. So in here we have a rectangular area, okay, that's it, that we need to fence. So this is the first side, this is the second side, okay, and this is the third side, okay. And over here, we need to put a fence, and of course, we have a river. Okay, for this side, we have a river. That's it. Okay, so we need to put the fence. Our fence, it will cover only three sides. Okay, so we will cover only three sides. Okay, so I'm not going to cover the side beside the river, so only three sides. So over here, if I'm calling the sides, for example, let's say if this part is equal or this side is equal to x, then this side is equal to x, and let's call this side as y. Now, I don't care if you would like to call this side as y and this as y, then this is x, that's fine, you can do that, okay? So it's not going to affect your answer. Be careful from that. So starting with just writing the relations that I have in the question. So they started by mentioning the area. The enclosed area is equal to 1800 feet square. So in here, this is area, which is equal to 1800 feet square. Okay, now find the minimum. Minimum what? So we need to find the minimum perimeter and the dimensions of the corresponding enclosure. So in here, we need to find the minimum perimeter. So we need to minimize the perimeter. So in here, we need to find the perimeter. Minimum value for the parameter. For finding the minimum value of any function, okay, we need to find p prime, okay. Then after that, we will use the number line test to find the minimum value. So starting with the given with me. So in here, area is equal to x times y, okay. Actually, for this given relation, I would use it for substituting in the second relation, which is I need to minimize or maximize, which is over here is the parameter. So If A is equal to x times y, this is a rectangle, okay? Now that means A over y, okay, is equal to x if you would like to substitute the x, or A over x is equal to y if you would like to substitute the y. Now in here, let's substitute the y for example. So area is equal to 1800 over x is equal to y. Okay, good. So I will use this relation for substitution. Okay, good. The second relation we have in here, which is the parameter, which is equal to all the summation of all the sides that we need to fence. This is 1, this is 2, this is 3. So I have x plus x plus y. So now I will substitute the value that I have because I need just to try to convert this relation to be written in one variable only. So parameter, it will be equal to x plus x, which is 2x, plus, instead of y, I will write 1800 divided by x. Now it's ready. One variable only, I have x in here, so I can start by finding the derivative. So over here, p prime, this is equal to the derivative of 2x, this is equal to 2. Then plus the derivative of this expression, this is equal to minus the constant, multiplied by the derivative of the denominator over the denominator square, which means it's x square. Okay, good, perfect. So now after that I can make the denominators the same. So this is 2x square. So 2x square minus, yes, 1800 divided by x square. So now for finding, now I'm just solving the same as what we've done in the critical numbers part to find the increasing and decreasing intervals. So we need to find the derivative, then after that I'll find the zeros and the undefined values, etc., all of these things. So zeros, so in here I will take 2x squared minus 1800, make it equal to 0, and let's see what is our answer. So over here it will be, using my calculator, it will be after taking the, okay, I need to change the pen to a blue one again. So this is going to be x squared equal to 1800 divided by 2, which is equal to 900. Okay, then after that I need to take the square root for both sides. So x, it will be equal to positive negative 30. Okay, so that's it. X is equal to positive negative 30. Now from the undefined values, it will be x squared equals 0, which means x equals 0. Okay? Okay, good. So now I need to check which values are included with me. So in here, I will go back to the original function, which is 2x plus 1800 over x. Now for this, the domain is r. Now for this, it will be r minus the 0 of the denominator, which is 0. So the total domain, it will be r minus 0. So the 0 is not included with me, so I'm going to reject this value, okay? And I'm going to take these two values. Okay, now that's it. This is the number line. Now before start substituting the values, we said that we have x equal to positive negative 30. Okay, now we cannot say that the length of the fence or the length of the side is equal to minus 30. So logically, mathematically, it's correct to take the positive negative 30. That's correct 100%. But logically, it's incorrect. So instead of taking these two values, I will take only what? I will take only the positive 30 and for the negative 30 it will be rejected because we cannot have a side with a negative length. Okay, so in here the logic it says that we have to start from 0, okay, until the end. So in here we have 30, which is positive 30. Now we can substitute any value in the derivative. What is my derivative? That's it. This is my derivative. Okay, so I will substitute any value less than 30 and greater than 0 in this. Okay, let's say I have 1, for example, so 2 multiplied by 1, which is 2, then minus 1800. This is going to be negative over positive, so that will give me a negative value. Okay, now after the 30, if you take, for example, let's say 31, 40, whatever, after substituting, you will get a positive value. That means you have increasing. So in here, this is decreasing and this is increasing, which means in here I have minimum value. So I have minimum, local minimum at x equal to 30. Okay, 30 fit, sure. Okay, in here we can find the parameter by substituting the 30. So in here I can find the parameter, which is 2 multiplied by 30, okay, plus 1800 divided by 30. Then I can use the calculator for finding that. So this is 60 plus 1800 divided by 30, okay, which is equal to 120 fit. This is the minimum parameter I have. Now I will calculate the y if they ask you to find the y value. So y is equal to 1800 divided by 30. So directly 1800 divided by 30, which is equal to 60. Perfect. That's it. This is my final answer. That's it. That's it. This is the end of this question. So let's move directly to the next question. Now, of course, for the second question, it's similar to the question that we have solved now. And here, as you can see, we have also three-sided fence to be built next to a straight section of river. So pretty much it's the same question. So I want you to practice and solve it, which is question 2. So that means we will move directly to question number 3.